Hi everyone. Welcome to the concept on identities. Now, identities are those formulas which you actually have been seeing right from your school days. The typical formulas which you've been seeing right from school days, right maybe from your 6th standard, 7th standard and so on. But some of them might also be new to you, or you might need to just revise them because these will form the base of your maths. Let's start with the basic formulas. The first one, the most common one, a plus b the whole square. What is a plus b the whole square? It will be a square plus 2ab plus b square. What is a minus b the whole square? A square minus 2ab plus b square. Third one is a plus b the whole square plus a minus b the whole square. That is adding the two formulas above. So if you actually add the two formulas above, what would happen? The 2ab and the minus 2ab would cut out and you would get 2a square plus 2b square, which will then become 2 times a square plus b square. The next formula would be a plus b the whole square minus a minus b the whole square. That is subtracting formula 1 and 2. And if you do that, you would cut a square out, b square out, and you would be left with 4ab. Next one is a plus b plus c the whole square. Now, how do you do that? Do you really need to solve out, multiply a plus b plus c with a plus b plus c and get the answer? Let's see what the formula is. It will be a square plus b square plus c square plus 2 times all the different combinations. That is 2 times AB, 2 times AC and 2 times BC. So let's just go through that once more. What is a plus b plus c the whole square? It will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Similarly, what will be a minus b minus c the whole square? Here you just need to be careful about the signs. So the squares will still be positive. It will be a square plus b square plus c square. Now minus 2ab, because a is positive and b is negative, so minus 2ab, minus 2ac, but plus 2bc. Why? Because b and c both are negative, so it will become plus 2bc. Similarly, if I have to go for a plus b plus c plus d the whole square, you now need to just extrapolate the same thing. So that will be a square plus b square plus c square plus d square plus 2 times all the different combinations. So what will be the combinations? It will be 2ab, 2ac, 2ad, 2bc, 2bd and 2cd. So please look at the formula again. A square plus b square plus c square plus d square plus 2ab, 2ac, 2ad plus 2bc, 2bd plus 2cd. The next formula will be a very standard one but a very important one. What is a plus b into a minus b? That will be a square minus b square. Let's go ahead with the formulas. The next one is a plus b the whole cube. What is a plus b the whole cube? So if you expand it using the whole cube formula, you will get a cube plus 3a square b plus 3ab square plus b cube, right? A minus b the whole cube will be a cube minus 3a square b plus 3ab square minus b cube. The next one will be a factorization formula. So up till now, most of the formulas which we did, that is a plus b the whole cube, a minus b the whole cube, they were all expansion formulas. While a cube plus b cube is a factorization formula. So it will be factorized as a plus b into a square minus ab plus b square. Similarly, a cube minus b cube will become a minus b into a square plus ab plus b square. Next is a very important one and maybe a new one for you all. A cube plus b cube plus c cube minus 3abc is equal to what? It will be equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. This formula as it is might not be a very important one, but the identities or the rules which we learn from this formula are very, very important. So let's have a look at it very carefully. There will be 2 things you will learn. First one, if I know that a plus b plus c is 0, so if you look at this formula and if you know that a plus b plus c is 0, which means your right hand side would become 0, then what would you know? You would know that a cube plus b cube plus c cube minus 3abc is 0. So in short, you will get that a cube plus b cube plus c cube is equal to 3abc. So very important rule that whenever a plus b plus c is 0, a cube plus b cube plus c cube will be equal to 3abc. This will really help you in a lot of division questions or the rules of divisibility. Next one, if a cube plus b cube plus c cube is equal to 3abc, which means I am already telling you the right hand side is 0. There are 2 possibilities because on the right hand side there are 2 brackets. So I could get first that either a plus b plus c is 0 or the second bracket is 0. Now, when the second bracket is 0, that is a square plus b square plus c square minus ab minus bc minus ca, it can be proved that a is equal to b is equal to c. So the other rule which you need to know is that if a cube plus b cube plus c cube is equal to 3abc, then a plus b plus c is 0 or a is equal to b is equal to c. Let's go to the next formula. The next formula is factorization of a raised to n minus b raised to n, irrespective of whether n is odd or even. So for example, I can use this formula for a raised to 5 minus b raised to 5. I can also use it for a raised to 6 minus b raised to 6 and so on. So let's see the formula. So the basic rule is that whether n is odd or even, a raised to n minus b raised to n is always, very importantly, divisible by a minus b. Let's go through that again. Whether n is odd or even, a raised to n minus b raised to n is always divisible by a minus b. So I will get the factorization of that as a minus b into, let's look at the second bracket, a raised to n minus 1 plus a raised to n minus 2 into b plus a raised to n minus 3 into b square and so on till b raised to n minus 1. So I'm just going to take a small example, just listen to that carefully. If I have a raised to 5 minus b raised to 5, so I'll get a minus b as one bracket. The second bracket will become a raised to 4 plus a cube b plus a square b square and so on so on. Right? Let's look at the next one. But what if n was only even in this formula? Now when n is even, that time a raised to n minus b raised to n is also divisible by a plus b. So I could divide it by a plus b and also get the second bracket as a raised to n minus 1 minus a raised to n minus 2b plus a raised to n minus 3b square and so on till b raised to n minus 1. Please carefully look at the signs there. The next one is again factorization of a raised to n plus b raised to n when n is odd. A raised to n plus b raised to n is divisible by a plus b only when n is odd. So you will get a plus b into a raised to n minus 1 minus a raised to n minus 2b plus a raised to n minus 3b square and so on. The last three formulas definitely are difficult, but they might not be used directly as formulas, but they will be very important when you will be doing rules of divisibility.